I'm joined by Dottie Metcalf-Lindenburger. Dottie, thank you so much for being here. You were an astronaut,
Yes.
a teacher,
Yes.
and a space camp graduate, correct?
That's right. Yes, that's all right.
And you also study geology.
Yes, currently a geologist.
You live in Seattle,
Mm-hmm.
so you have the Cascade Mountains.
Yes.
So we're going to ask you to talk about plate tectonics.
The interesting part about the Earth is that, of course, there are parts that act very brittle. That's our top crust part that we're going to be using here. And we call that, for a fancy name, the lithosphere.
Okay.
Litho meaning rock. And then there's the mantle below, and the mantle has a portion on the top of it called the asthenosphere that is a little bit plastic. So we're going to put that as our icing. It acts a little bit plastic. Okay, so our lithosphere is on top of our more plastic asthenosphere, which is really a part of, like we talked about, the mantle, which now we have this bottom crust, but it goes a long ways down.
Okay.
So on this brittle part at the top, we have things that act like plates. That's why we call it plate tectonics. And the plates move in different ways. We'll start out with plates that move past each other. This is what we call transform. They're transporting past each other.
Okay.
When they do that, as you can see, it really grinds up the crust. And ours is moving along a nice line, but rock doesn't behave nice, and it goes through, and sometimes it hangs up, and then when it pushes past, there's a big break, and that can cause some pretty significant earthquakes. And obviously, it's at the top of the crust, so people really feel it.
Now, can you see something like this from space?
Yes, you can see the San Andreas Fault from space. You can even see it flying. So we should probably talk about then divergent, because you're creating crust. And so these plates are doing exactly like we said, they're diverging. And when they do that, this asthenosphere is coming up and making lava, and it cools rapidly if it's underwater, really rapidly. And it creates more plate. In our model, there would be more plate being created behind it. Where there's divergence, there's also somewhere around the world has to be convergence. And convergence happens in many different places. There's both ocean crust and continental crust. Of course, we tend to live on continental crust. So where I'm at in Seattle, we have convergent plates. And what we have is an ocean plate that's going underneath continent like this. And when it does it, it of course scrapes along the base. And we have a set of mountains that are forming because there's sediment being scraped off. Those are called the Olympic Mountains.
Okay.
But behind, as this scrapes down, it starts to melt as it goes into the asthenosphere. And we have a line of volcanoes that form behind that. So Mount Rainier, Mount St. Helens, Mount Hood, all of those are famous Cascade volcanoes that are still active. And as we know with Mount St. Helens, very active. And convergence also happens between two continent plates.
Okay.
And when two continents crash, neither one wants to go under. They're less dense. They want to just keep pushing up. And I can't do this very well with graham crackers. They're gonna push and make these huge mountains.
Thank you so much for explaining this to us.
Yeah, it's so much fun, and it's a tasty snack, right?
Yeah, now everyone can have a snack. How is it?
Pretty good.
Pretty good.